is a hard one. Right. So the problem says you have a 2D grid of zeros and ones, right? And essentially what we have to find is we have to find the largest island that can be made in that grid. And what we have an option is changing one of those zeros to one. So at max, if there's a grid, we can change one of the zero to one. And what is the final, maximum grid, maximum island that you can create out of it, right? So let's suppose we have this 1001. If I say here 1, 0, 0, and 1. So right now, if I set 1 is here, you'll see that there will be a largest island, which is getting of these three elements, right? If I place either here or here, it will be 3, right? The other example that they are saying is you already have 3 elements. There's only 1, 0, and you set it to 1, you'll get all the 4 elements as 1, which is essentially a single island, right? And the case can be the already all one setup. So what will be the maximum island that you can make? So there's nothing to change. Already whatever is the maximum is what you can get, right? Okay. So essentially, and for the definition of island, what they're saying is an island is 4 directionally connected group of ones. That means if you have something like this, essentially everything on the right after the right diagonal is forming a island. Because somehow from the 4 diagonals they are connected. If this one is connected to the other one, and this is connected to the one which is on top. Does that make sense? Is the problem clear?
Yes.
Yeah, it is.
Okay. So any ideas? Let's discuss the approach and ideas about this one.
I think the simple brute force approach will be like start from each 0, whichever you get, and change it to 1, and then get the maximum length of island.
Okay, so let me share my screen and so let's say we have this 2D matrix. Right. So let's say we have some ones here.
Yeah.
Then zeros. Right. So what you're saying is
no pre-computation, no initial information, just whenever I get a 0, I change it to 1 and
right.
call a function which give me the maximum length of island in here.
Okay, so suppose you take 1 here,
DFS. Yeah,
and then you do a DFS which will calculate everything from here till here.
Yeah.
Right.
Yeah, I mean it will calculate the length of all islands and give me the maximum value.
Okay, so for this one, suppose you found 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and you have something like as max. Right now you have one max is 10, correct?
Yeah, and then I
now you go ahead.
Here. Yeah.
You again do the same thing. You set it to 1, right?
Yeah.
Suppose this is 1, and you calculate this again area.
Yeah.
And then you find again the number, which essentially in this case will be 9.
Yeah.
Right, and it is not maximum, so you not set it.
Yeah.
And you will do this activity for all the nodes which are there, right?
Yeah, and whatever maximum I had, I will also store the index. So later I will, if I need the information to return the index also, I mean, not for this question, but I can have that information also. The index information where I'm changing it to 1. The simple brute force I'm thinking, yeah.
So did you see something here? Like if I'm doing set 1 here, I'm trying to calculate everything here, right?
Yeah.
And then when I'm setting 1 here, I'm again trying to compare everything which I have already done, right? So this left part is getting calculated or traversed again and again.
Again and again, yeah.
there a way we can reduce that?
I mean, something like I can pre-compute this information, like whatever, without even changing any bit, I will just have the information about my islands already. So if I change the left island to the very first zero, will have size of like 8, and the right island,
Sorry,
right side.
what you're
So
saying about what will you change there?
the very first zero you have, right? The
Mm-hmm.
30, this one, yeah. So I will
Right.
get the island size on the left of it.
Okay.
I currently this is of size 8, right?
Right.
And there is a right island also, which is of size 2.
Correct.
And the island under it, 0. And island on top of it is 0.
Correct. So this is 0 and this is 0.
Yeah. So when I change this bit, I will just need to add those 2 island plus one more length,
Correct.
right?
Okay.
Something like that may help.
So
But
you're saying how will you identify whether what is the size of this one? First step is that you have to calculate
yeah,
the size of
Can
this island,
we
right?
make any kind of a map or something where we can store the island's max value, that particular
Uh,
island?
yeah. So what? How will you represent this map? That's what the question is.
yeah. So
So
I need to
let's
change
say
this
you
value to island. I mean, any ij value can give me the island number to me.
let's say this one is island one. This one is island two. This again is island three. There's only one. This is four, and this is five.
5.
We
Yeah.
can give any XYZ value to these islands, like
Okay, and how will you know that whether this point is related to that xy?
all the islands which like how the island problem we solve, like we find one particular island of this group, and
Right.
we gave them like something an X island, a name to that
Correct. So
island.
I understand what you're saying. My question here is, or the problem here is, the first time I'm here, I know this one on the left is giving a size of 8, suppose island 1.
Yeah.
So
Yeah.
now suppose you're processing this one. How do you know this point belongs to island 1?
What we can do is we can store all the values, if like you have this island one and its size is 8, let's say. So we can store, we can make a new 2D array wherein we can store, like 8 everywhere for
Mhm,
all the values. So whenever we'll be trying to, if I put one adjacent to this island on any
mhm.
zeros, okay, matlab on any
Right.
zero, if I replace any zero with one, so I
Mhm.
could check if there is, some non-zero number adjacent to the place where I had put my one. So if there exists some value like that, so what I can do is I can simply turn it to 9, and I'll get the maximum value like that, something like that.
Correct. So that's one of the approach that you're saying. So you can have a 2D matrix where you can store each index, I suppose 0, 1, 0, 2, 0, 3,
Uh,
and then say there's
uh, no, no. What I'm saying is we can replicate the same matrix, and instead of storing 0 and 1, what I can do is I can store the island size.
let's say this one.
Yeah.
Then you have this much, and then you're saying it will be 8.
Yeah. So
So
8
then
for
8.
all the places. Yeah. The whole island. In this way, for every discrete island we have, we can store its number initially, its size initially. Sorry.
Okay.
Size
Uh,
But there
ID.
can be another island which also has size 8.
Yeah.
Yeah, that's not a problem. What I'm saying is, see, if suppose the size of island 2 is also 8, okay, so you even write 8 here, there. So for the next time, if we put in the original matrix, if we put 1 somewhere in the third column, okay, so and I'll then check after putting 1 if there is any adjacent island to it. And if I get that, I can simply add it to the like add the value to the same, and then I could update the whole island or something like that.
So what you're essentially saying is run somehow find the group of islands,
Yeah,
and then in this new array or new 2D matrix, replace them with their length.
yeah,
Right? Suppose we have these metrics which are giving the length as 8888, right?
yeah. There could be some
And
other
now
island
what?
with any other
Yeah,
assignment.
let's assume we have 0 here, 0 here, 0, 2 here, 2 here, 0, 0. Let's anything values,
Yeah.
any set of values. Now what? Not what will we do with this one?
Okay. Yeah. Now, if we check for all the zeros by replacing it by one. Okay. So suppose you take any zero and replace it by one for now.
Let's replace it by 1.
Okay. Yeah. So now I'll check if there is a non-zero number adjacent to this cell. Like
Okay,
I
so
have
there's a
here.
non-adjacent number. Yeah.
Yeah. So I could update this number, or I could keep a max number where I could store 8 plus 1. That will give me 9.
Okay.
Okay, for now I get that if I change this value, then I'll get a 9 as maximum.
Correct.
Similarly, I could go to other cell and then check and make the maximums. This way I
Right.
get, will
Essentially, what you're doing is taking each 0 and seeing what is on the 4 directions of it and trying to sum that up.
yeah.
Right? That will give you what is the maximum size that you can do by replacing one of the zeros. Right?
Yeah.
So now this is fine. This approach is fine. Now my question is, do you really need this secondary array?
Puneet, 1 minute. Actually, this I will show why it will fail unless we actually put also the info that which island it belongs to. So in the same example, go to the 0, which we were there.
Sorry, Raju, I could not hear you. Could you please repeat?
Yeah. Can you go to the first 0 on the first row?
Okay.
And
This one?
yeah.
Okay.
And suppose my island was part of just below the 0, there is another 0. Make that guy 8.
Yeah.
Yeah, make it 8. And these islands are actually part of one island, So now when this guy will go to the left, it will add 8, right?
Right. It will become 60.
But that was the same island, so you are double counting. You understand where the problem lies here?
Yeah. So that's what I was saying. Like instead of size, we should have a unique number or any other identifier.
With size, if you also add this as a pair, then it is good enough. Like it's implementation detail, but you should store that
So
in this
I think
approach.
what we can also do here is, as I was saying, to sum up all the four, just the four of its adjacent cells. We can check the other four as well. That will give us an idea somehow if it is the same island or the other island. So in that case, I think we can minimize our cost. Sorry, not minimizing. We can minimize this error. We can counter this error. Hello?
I did not get what you are talking. So could you just repeat the?
Yeah. What we were doing here is what I was saying earlier was to sum up, to check all the four or all the four adjacent cells to the cell where we are changing it from 0 to 1. Okay, and then to sum that up. But Roger has come up with a brilliant, example where this method fails. So what I am saying is there are 4 more adjacent cells to the same cell where we are updating the value. Okay. Hi. Am I audible?
Yeah. Go ahead. That's correct.
Yeah. So we can even check those cells and we can have a clear idea if the cells that we are adding are the same island or the different. In that way, I think we can keep track of.
But in third row, third column, if you see 0 there, right?
Yeah.
I will never able to understand like which 8 belong to the left side and which 8 belong to a different island, right?
What he meant was also checking these four directions.
Yeah,
The
yeah.
okay, okay, got it. And then I
And
need to
checking
identify.
these four, I'll get an idea if that is the same island or the other one. In that way, I could come up with the idea to add whether to add or not.
The problem is by number you cannot conclude. You will always have some example which will break that. Most likely, it will be a good question to solve and suggest on that chat. Like, try that actually approach. I'm not sure. Maybe it will work, but not sure.
Yeah,
No, actually, it will either be related to this one or to this one, right?
yeah,
In
Yeah,
fact, if there's a number, non-zero number here, it has to be same as these two. Because
yeah,
by the definition, they will be forming an island.
yeah.
yeah.
But
So
we
if there's a
can
number other than, yeah, sorry.
yeah, sorry. But we can simplify this by just maintaining this size information somewhere else and keeping it a different value like island number 1 everywhere. Instead of 8,
Correct.
it will have a number like island number 99, island number 100,
For
island
me,
number.
yeah, for me, the one of the approaches is to use a disjoint set. So each island will become a disjoint set, and the root of that or whatever is the identifier for that will hold the total number of elements. Then if we have, let's assume this same case where on the other side you have 8 here. What I need to check is just get from here, get the island number or the root identifier for this. Suppose I am calling it as 1. Then check for this one. If I've already calculated this, I'll not go ahead and use that one again. I'll go the other direction and check if there's another island number in my opposite vicinity and then sum it up. Right? So each of these numbers can directly give me the island identifier. So if I am at this position, I'll know what island it is connected to and what is the size of that, right? Does it make sense?
Yeah, it does.
Right, so essentially, this is one of the intuitions that I usually have for the disjoint sets is if my data points are mutually exclusive and I just need one name or identify, like we earlier said, let's identify those with 1 or 2. This is my intuition that if I can use a disjoint set for this one. And then, of course, these points need to have some kind of relation, which is already given in the problem, right? Any other approach, anything else? Or any problems with this one?
I have a question. So while you're saying that all these are having a relation, so is it like we are storing all the data points of that particular island and giving them a particular ID? But like how?
So the disjoint sets or union find algorithm, they work in a different way. You have this parent array, okay, and you have it's not even an array. No, it can be array, it can be a map, something like that. You map each of them and store the parent of that. So or the identifier. So suppose there's an index called 0, 1, and I have all of this saved as a row major index, row major array instead of 2D. So this will become my index 1, right? This will become my index 2. This will become my 1, 2, 3, 4, 5, 6, 7, and that's right. So for each of that, suppose 1, I'll put 1 as its identifier. And when I'm doing traversal, right? So as and when I move to some other, I can update its, parent identifier to what is a root identifier for what I have decided the root identifier till now. So everything 1, 2, 6, 7, they will all have identifiers 1. Right? Now every time I'm just looking at this one, I'll just calculate what is the index in the entire array, try to find what is the max, index or the identifier for the group. It's 1, right? So, and I'll suppose I have another array which will just store, for index 1, size is 8. I'll just take it up and sum it up for this entry, right? I have 8 plus, if there's another 1, suppose the 1 is here also, 1 is here also, so this one will flow here also. You will have, suppose, 10 and 11 also pointing to the same root. I'll come here, I'll find what is the parent for this one, or identify this entire set. It will again give me 1, but I already counted 1 in my calculation, so it will not count again, right? So it's the union find or the disjoint sets. They have a separate way of finding the optimal, not optimal, but the single identifier. And there are some optimization techniques also associated to that individually. So I would suggest take a look at that. It's a very easy to implement and very easily understandable way of identifying some set of data points which are related.
Okay.
Anything else, Roger? Do you want to add anything?
I have a question.
Yeah.
Have this huge parent array.
Sorry, I'm not able to actually hear you.
Hi.
Hello.
Am I audible?
Your voice is breaking. I don't know. Is it me only or everyone is having that issue?
It is breaking actually.
No.
It is breaking.
Okay.
I think my internet is troubling. I don't know how to handle it.
Yeah, go ahead. It's better now. You can go ahead.
Okay. So what I was asking is it really necessary to maintain this huge array, the parent array, like you're written? Rather than this, could we do it something like we maintain a hash map, and therein, for example, we number these islands by 1, 2, 3, 4, 5, and in the hash map, the key is the number of the island, and the value is the weight of the island. So in that way,
Okay.
we could fill a newer array of ours with these these distinct keys for each element, and whenever we'll be searching out, we could just sum up with the surrounding keys, something like that. The value of this.
How would you find that whether, yeah, how would you find whether this index is actually associated to island number 1?
Okay.
You need
If
some way to identify that also, right?
yeah, for that we could maintain a new 2D array, like we did in this case.
That is
Where,
exactly what this parent is doing. It just
oh,
converted that 2D array into a single
Okay,
dimensional
okay.
array, which is row major.
okay, yeah, got it. Thank you.
But you can, for simplicity, you can use this parent array as a 2D. If
Mhm.
that gives you easier access or easier implementation for you, it's fine, because the size of this array will be same. And if
Yeah.
you want to reduce that, instead of array, you can use suppose a lookup, which will just give you lookup from current index into the final identifier for that, right? It's
Yeah.
up to you. It may happen that the entire grid has only 2 ones and rest all is 0. So you don't want to, burden your parent array
Got
or
it.
parent lookup identifier, right? So it's essentially a lookup service or a lookup data structure, which will help you immediately identify what will be the identifier for this group where this index belongs.
Yeah, got it. Thank you.
Yeah, the only thing I would like to add, like that the problem we were trying to solve is like we go to a zero, and then zero asks its neighbors, "What is your size?" And uh, it again asks the same question to other neighbors. We have to somehow identify that they are not talking about the same. They are not part of the same group, basically, right? Because if that was not the problem, it's okay. But we got into that double counting problem. So union find by its very nature has that property that everybody just talks, lets the actually leader talk for him. So it will allow, hey, I don't know, let me ask my parent. And for each guys in a group, the parent is same. So they don't get into the trap of double counting. With DFS, what you could have done, actually mapping is one example. The other thing is you can change the value because now you only have 0 and 1 value. Suppose each island has its own value, say 2. Another island has all its value as 3. So, so just by mutating that, you can see if I see this my neighbor is 2, actually know they are part of the same island. You understand what I'm saying?
Rather, that was the approach these were using, right? Instead of number, they were setting it up as
No, they
the
it's
count.
they were they were just counting it, right? But
Mhm.
yeah, it's similar to that. Like now you have that that value 2, and as long as you have a map that I'm my size is this one, you know that I'm part of that. Yes, so actually the same thing in a different way I was thinking, but yeah, essentially means the same. So the thing is union find, that is the difference. Like union find by its nature gives you, so you don't have to think about it. With DFS, we have no way unless we start storing that information, right? Because normally we just don't put that information in like in a normal island problem, for example. We just count the size and we are done. So that's it actually. Not much. Like,
May I ask a question? What's the complexity of the unified or DFS? Which one is better?
so both will have the same. Like,
Okay, thank you.
yeah, O of Mn, I think, because you will go to all the cell, and then even space, you will probably have, yeah, you will have O of Mn size.
Mm.
And then what he was saying, Puneet was suggesting that for the best complexity, if you're using union find, you should use path compression, and that will give you the best possible, that will give you actually O of Mn. If you don't do that, then it will be more than that.
Yeah. Thanks, Roger, for the explanation. Any other question or anything else that we want to discuss about this one? Okay. No. Probably then we can